right. Hello, everybody. My name is Sunay. I'm the Vice President of Research and Development at Open Networking Foundation. Today, I would like to tell you a little bit about our SD-RAN project in the context of a multitude of open source projects that we have in OpenRAN. And I would like to start my presentation by thanking Layer 123 for inviting me to participate in the OpenRAN webinar. So as we all know, RAN is undergoing a significant transformation. The pillars of this transformation is disaggregation, virtualization, and SDN. And open source is also playing an important role here. Our journey in this transformation starts with an architecture that has none of these features. Until recently, all radio access networks have been very tightly integrated with vendor-specific interfaces. At each tower, we had the RF units and antennas mounted with a baseband unit at the tower base where the RAN protocol stack ran. And even though various organizations, such as Small Cell Forum, had some open interface specifications, for the majority of the cases, the interface between these components were vendor-specific. And further, each vendor had its own portal to configure, control, monitor, and log their own equipment. And this portal had vendor-specific interfaces to operators' OSS, BSS, as well as regional self-organizing network control platforms. And speaking of the protocol stack, at a high level, the base stations we're talking about are responsible from two fundamental tasks: conducting packet and signal processing to transform IP packets to physical layer packets and vice versa, and also to control the mobile link, which is inherently a broadcast link shared by many devices over fast time-varying conditions. And the base station uses the protocol stack that I just mentioned to deliver on these tasks. So let us now look into the RAN transformation with OpenRAN. This will take place in two dimensions. First is the disaggregation of the RAN stack into 4 components and realize them in distinct locations. Our radio units at antenna sites, distributed units at cell sites, and central units, which are control user planes separated as virtualized workloads running at an edge cloud. And here, the user plane of the central unit will process and forward user traffic, and the control plane of the central unit will serve, again, 2 purposes: process and forward mobile control-related traffic, and also oversee near real-time mobile link control using radio resource management functions. We will then bring SDN-based programmable control to the RAN. This will introduce a near real-time RAN intelligent controller, or the RIC, to the architecture as the SDN-based RAN controller. And running on the near real-time RIC platform, we will have numerous RAN control applications called xApps by ORAN. And in a true SDN fashion, this will allow us to potentially further disaggregate the control plane of the central unit, lift the radio resource management functions that delay budgets allow from it, and realize them as xApps. And once we have the near real-time RIC platform, this also becomes a unified place for self-organizing network applications and policy-driven applications as well. And this architecture clearly opens up the possibility for new players and new innovative approaches for xApp development using ML and AI techniques. And some of the RAN control will take place in non-real time. So a non-real-time RIC will also be part of this architecture. And adding the service management and orchestration platform along with the cloud management platform gives us the official ORAN architecture. So with this in mind, now we can talk about SD-RAN, ONF's open source OpenRAN platform. At the heart of SD-RAN is an ONOS-based RIC that is cloud native and microservices based. And naturally, this platform is designed to support a variety of RAN control applications. And with a multi-language SDK support, the aim from day one has been to make it easy to write and deploy these applications on the platform. We have a rich ecosystem around xApp development within SD-RAN. SD-RAN also includes an ONF enhanced ORAN architecture compliant version of the OpenAir interface open source RAN stack as a reference design. But of course, connection and interoperability with commercially available small cells and base stations from the ONF ecosystem to SD-RAN and achieve broadband connectivity at scale and with high availability is one of the primary goals of this project as well. And we have a rapidly growing ecosystem on this front. So as this webinar attests, OpenRAN is a critically important aspect of the ongoing telco network transformation. So as a consequence, you see a fair number of organizations participating in specifying open interfaces and developing open source solutions to associated components, the disaggregated components. At first glance, this may seem like there are too many cooks in the kitchen. But to a large extent, these organizations are functioning in a collaborative and complementary fashion towards a common goal. And this collaboration is going very well and is starting to bear fruit. I've already talked about, in this context, our development focus within the SD-RAN project. And of course, ORAN Alliance is the organization where specifications for all components and interfaces are being developed. And the ORAN software community, hosted by Linux Foundation, is where partners develop and contribute open and binary solutions for the disaggregated components. And our SD-RAN project is marching forward not only towards a production-grade RIC platform, but also empowering joint work towards shaping ORAN specifications and TIP efforts in line with ONF operator partner desires. So as a consequence, we have a joint task group within SD-RAN that includes ONF, AT&T, China Mobile, Facebook, and Deutsche Telekom, where we regularly get together, discuss new ideas towards specifications, form consensus, and contribute them to ORAN Alliance. And of course, the ORAN Alliance specs, as they're updated, are taken in by these organizations, SD-RAN, OSC, and TIP, to further fine-tune their solutions. So needless to say, ONF is an ORAN member, and we actively participate and contribute to various ORAN working groups. And ONF and ORAN OSC have recently started a close collaborative work on architectural and platform development for what we collectively call a Portability SDK. More on this in a minute. And last but not least, ONF and TIP's RIA group, under its OpenRAN 5G NR project, are collaborating now and streamlining their efforts towards our common goals. So let me quickly introduce the Portability SDK for the near real-time RIC. So RIC platforms may provide SDKs native to them to simplify the lives of third-party xApp developers. These SDKs would provide the necessary drivers to the developers so they do not need to worry about the understanding the innards of the platform that their app would be running on. So as you can imagine, there will be a fair number of RIC platforms in the market, some proprietary and some open source. Two of the open source platforms are the ONF SD-RAN and ORAN OSC ones. So both of these platforms have their own native SDKs. So as you can imagine, while both conforming to ORAN specs, their respective implementations are somewhat different. So the two organizations are now jointly working towards a Portability SDK that would unify the interfaces and drivers for the xApps so that they can be ported from one RIC platform to another with minimal, if any, effort. This is necessary so that xApp developers can reach the widest possible market in this space. So I want to end my talk with some exciting news. We will be trialing a top-to-bottom, end-to-end SD-RAN-based ORAN architecture with multiple RAN and xApp vendors and a tier 1 operator in the June timeframe. This trial will have all of the ORAN interfaces operational, from front haul to F1 to E2. It will be composed of nearly all commercial-grade components from various vendors, and proprietary and open source components will coexist in the trial. And we will demonstrate simultaneous control of 4G and 5G networks with near real-time RIC from SD-RAN and xApps using ORAN specified as well as proprietary service models. And with this ORAN architecture, we will enable also broadband access, of course, to real 4G and 5G handsets. And all the while, the 5G network will include advanced features like network slicing with multiple user plane functions at the edge. And we will operationalize all of this on a centrally managed multi-cloud, cloud-native platform. So with this, I thank you for your attendance and your attention. Have a great day.
Thank you very much, Oguz. You actually have the pleasure of rejoining Oguz for our OpenRAN super panel that will begin shortly. This will be an opportunity to hear from and have ample time to ask questions from our esteemed panelists from Telefonica, Vodafone, Telecom Italia, ONF, Mavenir Altistar, Winnovata, and this will be moderated by Avid Things Rocha. So I look forward to seeing you all there, and thank you again, Oguz.
Thank you.